Hey guys, so today we're looking at Algebra 3's 1.4, dealing with every contrarian's favorite thing to hate in math, complex numbers, aka imaginary numbers. So, we'll be talking about what is I, what is a complex number, adding and subtracting complex numbers, multiplying and dividing complex numbers. So, let's hop to it. Let's just skip all that. Let's look at this situation here. All right. Can you think of some value that if you were to square it, you would get -1? Hmm. Hmm. Well, if you tried -1 times itself. Wow, this is what am I, a kindergartner? -1. Man, microphone, you're totally in the way. -1 times itself is God, microphone. Can you not? Hang on, guys. There we go. All right. So -1 times itself is +1. All right. Well, that's a wrong guess. How about maybe maybe you're thinking, well, if -1 doesn't work, how about +1? Well, no, obviously that's still 1. Um, Now you're at a weird spot, right? The idea here is that there is not a number that you can square and get a negative number. If I can just erase all this. All right, I'm not actually erasing, I'm just drawing over in white. So, this was the problem. If you were to do the mathematical operation to solve for x, that is to square, and I don't want to use that color. I'm all that colored out. Say you were to do this, right? You would get x equals plus or minus the square root of -1. Well, then you run into another problem because you can't evaluate square roots of negative numbers and get real values, right? It's for the same reason, right? So we let I represent a unit that is equivalent to the square root of -1. This is like a thing that we have decided we want to happen. And it works out in computations to give, you can use I being the square root of -1 and use it in situations and it will still route you to real numbers, right? That's what we're going to look at later on. So right now you just need to understand that the complex unit is I, and that is equal to the square root of -1. I promise you, if you memorize this, you'll at least get something right on the semester 1 final and the semester 2 final. Then, if you were to square I, that means you take the square root of -1 and you square it. You get the square root and the square root cancel, and you get -1. So this is the idea that you can have these quote-unquote complex units, but if you do real operations to them, you can get back a real number, right? So that's why we kind of use it, because it's used to help us get to real numbers, right? So there's our complex unit. A complex number is a number with a real part and an imaginary part. So this is the real part. This is going to be some real number. And then this is your complex part, a real number tied to your complex unit I. So some examples of some complex numbers, like 4 plus 3i, 2 minus 6i, pi minus ei. Well, that seems like, well, that's not cool. But pi is a real number, and e is a real number, right? That's around 2.6 and around 3.14, right? But they're both real numbers. They're mathematical constants. So these are all complex numbers, right? So you can add complex numbers together. This lesson, we're going to blaze through it. You and me, I got faith. So you can add complex parts. Wait. I was just thinking about how great it would be if I was done with this, but it stopped me. Whatever. So if you add the real parts together and add the imaginary parts together, you will get your answer. So you take the real part. And this is just like combining like terms. The 5 plus the 7, and that's 12, last I checked. and then the negative 11i plus the 4i, and that is, like negative 7i. You add these two things together exactly like you would add them if the I was an x. 5 minus 11x plus 7 plus 4x. You do the same exact thing. In addition, the parentheses don't matter. Combine like terms. It's exactly the same. All right? Seems simple enough? To subtract complex numbers, it's exactly the same as you'd expect. You treat the I as if it's something separate from the real numbers, which it is. You can combine it with other i's, and then you go about life. You'd have to distribute the negative here, and you'd get negative 5 plus I plus 11 plus 6i, and then you combine like terms. I know, most of you were in my class last year. We did the same thing. So your negative 5 plus 11 is 6, and your 1i and your 6i make 7i. There's your answer. All right. Hopefully you guys got that. Next, you can multiply complex numbers. Again, guys, you just treat this like it's an x. 4x times 3 minus 5x, what would you do? What would you do? Well, that's not rhetorical, though I don't want you yelling at me. You just distribute, right? So you have 12x minus 20x squared. It's exactly the same up until here, right? But we have i's instead. So you distribute the 4i, and you get 12i minus 20i squared. Now, the difference is the I squared. Remember what we said I squared equaled, right? Up here, right? I squared equals negative 1. So we can replace I squared with negative 1. Wait. Here we are. So if we replaced I squared with negative 1, you'd have negative 20 times negative 1. And that would be 12i plus 20. Right, because the two negatives make a positive. And then in your traditional format, the real part comes first. Okay? So there's your answer. So you guys pause the video and try this. Good job. I'm sure that you got the right answer, or if you made some mistake, it was some easy mistake, and you're awesome. And if you didn't pause the video, okay, let's run through the scenarios. If you didn't pause the video, that means if you're a good student, that means that you already know how to do this, and you don't need to see me working this example. If that's you, why are you watching this at all? Just skip ahead. All right? If you already know how to do it, all right? And if you didn't pause it and you're not one of those people, then shame on you. You should be doing the examples if you don't know how to do the problems. At least start them, man. At least start. So here, what do you think you do? Well, imagine, right? You should have paused the video and been like, previously we've been comparing to if I looked like X. That would be 7 minus 3x and negative 2 minus 5x. What would I do in this situation? Think. Oh, right, I would FOIL. I would distribute this, and then I would distribute this. And then you would try to do that. And that is exactly what you would do, hypothetical student. You would exactly distribute and distribute, right? And you would get negative 14, and then distribute here, and you get negative 35i. And then here you've got positive 6i and a positive 15i squared. And that gets you, when you combine like terms, negative 14 minus 29i minus 15. Why minus 15? Well, I squared is negative 1, and 15 times negative 1 is negative 15. Combine that with the negative 14, and you've got negative 4. Wait, whoa. Negative 29 minus 29i. I feel like I've done this example before. Anyway, so that's it. There's your answer. All right? If you got that, if you paused the video and you got this, and then you resumed the video, and then you watched me do it, and you got it right, I mean, my God, you're such a model student. All right, so conjugates. Why I felt the need to put an exclamation point here when I made these notes? Man, I must have been. Who knows what I was thinking? All right, so the best way to define conjugates is to just show you what they look like. The original complex number is 4 minus 3i. The conjugate is 4 plus 3i. Boom. The original here, negative 2 plus 17i. The conjugate, negative 2 minus 17i. The main idea here is that the conjugate has its complex part flipped sign, right? You take the sign in front of the complex part and you swap it, right? That's all it is. So instead of 9 minus 38i, it's 9 plus 38i. It's always the sign in front of the complex part, not the sign in the middle. If this was negative 38i plus 9 for some reason, the conjugate is the sign in front of the complex part changes, all right, every time. If it's written like this, it's designed to trick you. Now, this right here directly contradicts what I just said, because it's the middle sign in the situation that it is written in standard complex number form, right? If it's in your standard form, then you change it, right? I like how my notes just immediately say, right, only in A plus BI form, right? Then this is true. All right. If I go through the effort of doing all caps, it's really something that I think you should pay attention to. A complex number times its conjugate will always follow this rule. So we probably did not like doing this, foiling business, simplifying, and all that kind of thing, right? You don't want to do this if you can avoid doing it. If you recognize that you're multiplying conjugates together, complex conjugates, if you realize that you're multiplying two complex conjugates together, your answer will always be that first real number squared plus the second real number squared every time. So if I multiplied these two things together, I would always get this first real number squared, so 4 squared, plus, always a plus sign, the second real number squared. Whether you want to think of this as negative 3 quantity squared or just 3 squared, it does not matter. It will always end up with the same answer, which would be 9. So if you multiply these together, you would get 16 plus 9, and that would be your answer once you do 16 plus 9. So here, if you were to multiply these conjugates together, it would be this real number squared, so 4, plus this real number squared, which is like, I'm not even going to pretend to know what that is. Some number, surely. And you add them together, and that would be your answer, right? I'm not going to bother to get out my calculator. Plus I left, no, I'm not going to finish that. So here we've got another situation. What would this be if you multiply these together? Well, it'd be 81 plus whatever 38 squared is, right? You guys following along? So why I have this space, I don't know. Dividing complex numbers. That's the real trick here. This is the real part that people hate, and rightfully so. This is a giant pain in the butt. So when you are dividing two complex numbers, you want to multiply by a fraction that is the conjugate of the denominator over the conjugate of the denominator. So here's the denominator. The conjugate would be 2 plus 5i. So there is your conjugate. And you'll see something interesting happen when you do this. So use the shortcut for down here. I'm gonna scroll up and use this blank space to work out this problem, okay? So I'll do the denominator first. So we got our denominator. And that's going to be the first real number squared plus the second real number squared. So that's 2 squared plus 5 squared. All right, I feel like I'm going to need to stretch this out, probably. We'll see. Here, you're going to have to go ahead and FOIL. So that's going to be 7 times 2, which is 14, plus distribute here, 35i, then distribute the 4i, that's 8i, and distribute the 4i again, and that's 20i squared. Then you are going to change this to a negative 20, because I squared is negative 1. Combine these like terms to get you 43i, and you still have your 14. The negative 20 and the positive 14 make a negative 6. So we've got negative 6 plus your 43i. And that equals negative 6 plus 43i over 4 plus 25, which is 29. I don't feel like simplifying that, do you? I don't think I did anything wrong. 20i squared, yada yada. That looks okay. There you go. That's okay. Well, wait a second. Wait a second. That's not okay. I lied. If the question said to state your answer as a complex number or to simplify the problem completely, it would expect you to put the 29 underneath both of these separately. The negative 6 over 29 plus the 43 over 29i. And if you write it this way, it looks like another complex number. You've got your real part and your complex part, giving you a complex number, right? So this is the ideal method to see these problems, or to see these answers. Oh, what else? We have to do something else, right? Wow, calculator. Yeah, here's another answer, or here's another example. This is the last example before the homework. So here, I want you guys to try to work this problem out. Right? Remember that you multiply the top and the bottom by the conjugate of the denominator over the conjugate of the denominator. So do that, simplify it out, split it into a complex number, and get back with me. Okay. Here's the conjugate. The shortcut is going to make the denominator 4 plus 1, right? That's 2 squared plus 1 squared. In the numerator, you just distribute the 5i in, and you get 10i plus 5i squared. I really like this black. It looks all artistic. So then you've got 10i minus 5 over 5, which is negative 5 plus 10i if you want to get in your traditional format, over 5. Then separate negative 5 over 5 plus 10 over 5i. Simplify those, negative 1 plus 2i. Awesome. If you guys have any questions over that or any questions over the homework, feel free, and don't just feel free, feel entitled to walk up to my desk and ask me a question, or say, hey, Mr. Dybel, sit up, stop doing nothing at your desk and tell me how to do this stuff, and I will be happy to help you, right? There's your homework. Don't be a lazy bum. Do your homework and turn it in on time and turn it in where you're supposed to turn it in, and I will catch you on the next one.